Good morning and welcome. My name is Ina Paricio. I'm a marketing manager here at EDB. I am going to be your host today for our webinar, The End of the Reign of Oracle RAC, PostgresBDR, Always On. I am joined today by Marc Linster, who is our CTO at EDB. Before we start the presentation and I turn it over, I'm just going to go over a few housekeeping items. Number one, the presentation is being recorded, so we will be sharing the recording as well as the slides after the webinar. And number two, the lines are muted. So if you have any questions, just drop it in the question panel. And if for whatever reason we do not have time to go over your question, we will be following up afterwards. With that said, I am going to hand it over to Marc to kick us off.
All right, thank you, Ina. So today, as Ina said, we'll talk about the end of the reign of Oracle RAC and why PostgresBDR is a really good replacement for Oracle RAC if you're going the Postgres way. So over the next about 45 minutes or maybe a little bit more, we'll go through the following topics. I hope that we'll have enough time afterwards to have questions. If not, please still post your questions, and Ina and I will try to get back with try to post an answer to your questions before the end of the week. So I'll spend a few minutes on EDB. Promise just a few minutes telling you what we do, who we are, and why we feel so confident about making statements like what I just made, that the reign of Oracle RAC is coming to an end. We'll talk a little bit about the difference between high availability and always on, talk about who cares about it, and then we'll dive into, how does PostgresBDR compare to Oracle RAC? Touch on Aurora, RDS, and are they better solutions, and why people make the switch. Now, we also have a lot of collateral, a lot of materials, technical white papers, etc., about PostgresBDR. I'll point you to them at the end of the presentation, also a bunch of case studies, so that you can follow up. And again, if there are questions, please don't be shy and ask them. So let me start with EDB, who we are, and why we're so excited about Postgres as a solution for the enterprise. Now, many of you, if you're in this presentation here, are probably already bought into Postgres, but just in case you still have any doubts about where Postgres is going or where it's coming from, can you build on it, etc., I'll just give you a couple of stats. One of them is from the Stack Overflow survey from 2020. And by the way, Stack Overflow just also published a new developer survey for 2021. It's about the same thing. Postgres definitely rules the roost with developers, right? I mean, you see here that Redis is a little bit higher as a most loved database, but frankly, I think Redis is an in-memory cache. It's not really a database. And MySQL just has a very large historical install base. If you look at the growing popularity on DB engines, where, by the way, Postgres was crowned as DBMS of the year for 3 times now, you can see that Postgres is really growing very, very quickly, whereas former market leaders like Oracle are actually declining. Okay, so that's one thing. Now you may say, hey, these are just the old developers, and this is just things that who cares about that? It's the old stuff. It's actually true too in the newer environments like containers. I mean, Datadog, a tool that's very popular to monitor databases and containers, is again making it very clear that in containers, Postgres is the #1 database. Again, following Redis, but my argument is it's not really a database, it's an in-memory cache. Very, very far ahead of those that you might think are more popular, like Mongo, for example. Okay, and then even let's go further, cloud native computing. The Cloud Native Computing Foundation in their tech radar of November 2020 is again positioning Postgres as the technology that is ready to be adopted now in the cloud. One may argue whether Redis and Elasticsearch are databases. I don't think so, but certainly Postgres comes in way ahead of MySQL, of Mongo, Cassandra, Aurora, etc. So again, Postgres is really, really doing very, very well as far as a technology that is winning the market. We at EDB, as a company who's been, very, very involved in Postgres since 2004, we're even ready to make a stronger statement. And our stronger statement is that we believe that Postgres is the most transformative open source technology since Linux. So that's a very, very bold statement, but some of us have our roots in Linux and with Red Hat. So we're actually understanding what the motion was 15 years ago or 20 years ago when Linux entered the marketplace. And this is very, very similar. So now, in order to make this happen, right, Postgres needs the same kind of high availability technology that Oracle has, or that DB2 or SQL Server, et cetera, have. But, Oracle is kind of the biggest player in the marketplace and really the source from which many of our customers come to Postgres. So that's why I'm talking mostly about Oracle and Oracle RAC. So if Postgres is to be the most transformative open source technology since Linux, then it needs to have the same kind of power of high availability. And that is what today's conversation is all about, to say, how do we assure that? So let me just go back a little bit to EDB, who we are, what we do. We're leaders in the market for Postgres. We've been recognized by Gartner for many years in their Gartner Magic Quadrant for operational database management systems. But we're also a leader in the community. We're not the majority of the community. We don't own the community. We don't command the community, but we're a very large player. Actually, we are the largest player in terms of numbers of contributors, for example, to Postgres 13. Okay, as listed by from an analysis of the release notes. Okay, so again, we're a very large player in Postgres, but we're not the only one, and we're not the majority. But we play a significant role both commercially and in the development of Postgres as a Postgres community effort. If you dive into Postgres and look at the hackers list and look at who's doing what in Postgres, you'll see a lot of these names and many, many more names. But these are names that are really driving Postgres forward and that are with EDB. For example, Mike Stonebreaker, he was the creator of Postgres over 30 years ago at Berkeley. And he is today an EDB advisor. Bruce Momjian has been with the Postgres community since it was created. He is a member of the office of the CTO. Peter Eisentraut and Robert Haas are architects driving significant contributions to Postgres. And then Simon Riggs, he is the former CEO of Second Quadrant, a company that EDB acquired last year, and he is a Postgres fellow at Enterprise DB. So what's very important is we're recognized in the market by people like Gartner and many customers. We're deep contributors to the community, and we have significant expertise on board with over 300 Postgres technologists and 29 listed community contributors and committers. So we have really a lot of bench depth about Postgres. And as you can tell, we're quite passionate about Postgres. So what do we provide to our customers? Well, we provide obviously PostgreSQL. So we support PostgreSQL. We work with the Postgres community in providing PostgreSQL. And then we also have our own distribution of Postgres that we call Postgres Advanced Server, which is Oracle compatible, meaning it natively understands PLSQL packages and a lot of other additions that Oracle has made. For example, Pragma Autonomous Transaction. So 2 database distributions, open source Postgres, and then Postgres Advanced Server, all supported by tools for high availability, manageability at scale, integration with the rest of the enterprise, and then migration tools. And those tools are needed. Today, we will focus entirely on high availability. Right? You need high availability tools in order to get as much value out of Postgres as you could possibly get out of it. But you also need to be able to manage it at scale. You need to integrate it with the rest of your environment so that you don't create data silos. You want to be able to migrate to Postgres so that you're not stuck on, let's say, DB2 or SQL Server or MySQL or Oracle. And then last, but certainly not least, the deployment platforms. EDB Cloud today is our DBaaS in preview. It's been going into preview on August 16th, and it's going to go GA later this in Q4. But our software is also available on the IBM Cloud and on Alibaba Cloud. And then many customers run it either virtualized, containerized, or bare metal in their own environment. Okay, so it's really a complete portfolio offering for Postgres with everything that you need to be successful with Postgres. Today's focus is going to be on extreme high availability. Okay, so enough talk about EDB. Let me dive into today's topic: high availability or always on. We call it always on, and you may wonder why. But before we dive into that, Ina, can you just run the poll for us?
Absolutely, Mark. So, all right. So the question is, how do you achieve high availability for Postgres today? Option number 1, no special precautions. We use Postgres single nodes. Option number 2, Postgres with streaming replication and manual failover. Number 3, Postgres with streaming replication and automated failover, EFM, Patroni. 4th, Postgres with external tools. And lastly, Postgres with logical replication. Otherwise, there's the other option for people. So I'm going to give this 15 more seconds. Just make sure to put in your...
Yeah, we're really interested, and for everybody to know, we're going to share the data, not who voted for what, but the summary data also as part of what we send out after the call. I think this is going to be really interesting to help us all understand what are the tools that are used today for high availability with Postgres.
All right, so let me end the poll now.
Okay.
And we have 42% Postgres with streaming replication. And then 36% Postgres with streaming replication and manual failover.
Mm-hmm.
And yeah, 21% Postgres with logical replication. So
interesting. I mean, really cool. Obviously, streaming replication is the classical way to go. It's relatively simple to set up. It's very robust. I'm glad to see that the majority or the larger part of the respondents actually use a tool to do the failover so that they don't just replicate the data and then have to wait for a DBA to intervene if there's a failure. So I think that's really good. And the low usage for the older tools like Londisk, Bucardo, or Saloni is expected. I mean, those were valiant contributors to early versions of high availability, but their use is really declining. And then logical replication is relatively new, and we'll talk a little bit about the strengths and weaknesses of logical replication as a high availability tool. All right, let's move forward then. Okay. Okay, so you may ask, why high availability and always on? Is it not the same thing? Well, maybe it's two peas in a pod, but I don't think so. I think you really need to think about always on differently today. Historically, high availability meant like a software protection against failures. And that life also assumed the existence of maintenance windows. And the leading tools in that was like, Patroni, Stolon, Rep Manager, EDB Failover Manager. So there were a number of tools that could very valiantly protect you against hardware, network, or software failures, okay? The key thing was that the classical definition of high availability assumed the existence of maintenance windows. Now, what has happened is with digital transformation, maintenance windows have really disappeared. They've gone the way of the dodo. I was an IT manager many years ago, and we could do all of our stuff starting Friday evening at 6 o'clock, and we had till Monday morning, 8 o'clock to do whatever we needed to do. Those huge maintenance windows and batch windows, etc., they've all disappeared. In digital transformation, it means zero downtime. You're always on, right? I mean, today, for example, we are a Salesforce user. Salesforce advises us when there's a 5 to 10 second outage coming up. That's how demanding the world is today. And many of our customers today are, let's say, in credit card processing, or in the payment industry, or in the security industry for single sign-on software. And that stuff needs to work all the time. There is no time when, let's say, the credit card swiping doesn't work, right? I mean, 5 or 10 years ago, stores used to still have the paper slips so they could manually record a credit card transaction in case the little gizmo didn't work. They don't have that anymore today. It just has to work. And it mostly does work all the time. So near zero downtime today is different from high availability because it means including maintenance. It's always on. So it's really important that software that is used for Postgres in very demanding digital environments allows you to operate Postgres in an always on mode, not just in the mode where you can survive a hardware failure, but something where you can do most maintenance operations without taking the system down. ITIC in their 2020 survey has shown that today 4 nines is considered the minimally acceptable level. So 4 nines is no longer like the tip of where, or the epitome of where you would like to go. No, it's like that's like the baseline. That's table stakes. Everybody needs to have that. So you may say, hey, what's the big deal? Well, this is this table, which many of you are probably familiar with, kind of summarizes the challenge. It shows you in minutes and seconds how much downtime you have if you achieve 4 nines or 5 nines. So really, there is no time. There is no time to do maintenance. There's no time to take the system down to do maintenance. So maintenance is still needed, like patches, updates, security fixes. I mean, our experience says you need to do that at least 4 times a year. Like with Postgres, there's at least 4 maintenance releases per year. Sometimes there's a security patch that needs to be applied, right away. And if you want to run at 5 nines, you can't take the system down to do that. It just doesn't work, right? So you need a piece of software that allows you to do maintenance operations while the whole system is running. And that's really the biggest difference between what we used to call high availability and what we now call always on. So let's dive into that. Who cares about it? Well, again, this survey from ITIC, which we share the link with you if you want to, really shows that the majority of companies today know that an unplanned outage, like an hour of unplanned outage, costs hundreds of thousands, if not millions of dollars, right? And it's pretty clear. If you're taking payments online, and if you have an hour outage, you don't need to take a whole lot of payments before this becomes really, really painful from a loss of revenue perspective. Now, what is worse is you will also suffer a loss of customers. I mean, we support a lot of payment gateways around the world, and even seconds of unplanned outage drives them to call us to say, hey, you cost me customers. That can't be. And that's why understanding and embracing the concept of always on and saying, yes, I need a solution that is always on, not just highly available, and then I take it down a few times a year for maintenance, for patching, but something that is built to run while you do the system maintenance is extremely important. Okay, so let's talk a little bit about PostgresBDR. So PostgresBDR is really the next step in Postgres replication. And if you want to read up more about this, I'm giving you the links to several white papers that describe, for example, this graphic here in detail of work that was done over the years to add capabilities to Postgres to make replication, which is the way we do high availability and always on in Postgres, to add capabilities to replication to make this work better. As we saw in our survey, the first generation replication or high availability tools, Londisk, Bucardo, Sloaney, they were add-ons to Postgres. They were not built into Postgres, and they were very important contributions to Postgres. But then came streaming replication, as an evolution of log shipping. Log shipping, I think, had been introduced in 8.3, if I remember correctly. Streaming replication came with Postgres 9. And then came hot standbys. So standbys that are always in, or that are close to synchronized, that can be used using synchronous or asynchronous replication. And then came logical replication, right? So, big thing about logical replication is that you can do it across versions. Streaming replication requires the same major version. Logical replication works across major versions. So you can sense already, hey, there's a way for me to do major version upgrades without taking the whole service down. And then came things like DDL replication, which is also really important, right? Because there's always things that change in the system, especially in an agile environment. So in this environment here, you can see how Second Quadrant and EDB contributed throughout the versions to bring more and more capabilities into Postgres to make replication more and more powerful. Okay, so you may ask, well, Postgres native logical replication, isn't that good enough? I mean, as we saw in the survey, quite a few people use logical replication for their high availability. Well, the problem is that logical replication out of the box doesn't replicate DDL, which is a real problem because no system, especially not today in agile environments, is like stable as far as, there are no DDL changes ever. There's really no built-in failover logic into in high replication. It doesn't integrate in logical replication. It doesn't integrate well with backup and recovery. It doesn't have any built-in procedures to do maintenance, updates, upgrades. And, as far as cluster awareness goes, it really is not cluster aware. So it can replicate from A to B, but, there's really no good way to go back or to say, hey, I want to add a third participant to my cluster, etc. So it's a really good building block, but it's not a complete high availability solution, at least not in our view, and especially not when we're talking about 4 nines or even 5 nines of high availability. So in comes PostgresBDR. PostgresBDR, for those of you who have been involved in Postgres, has been around for a while as BDR. So there was BDR1 and 2, and today we're talking about what used to be called BDR3. So it's a third generation of BDR that really builds on logical replication, mesh-based replication networks, and multi-master. So what it does is it adds automatic DDL and DML replication in this, what we call the active-active mesh network. So there's not like a circle of replication, like where A goes to B, B goes to C, C goes to D, etc. But it's really all participants in the cluster who talk to each other in a smart way to, again, minimize the amount of traffic that happens. It is built in the failover and switchover infrastructure to reroute traffic. And that's important because you need to do maintenance, right? It's not just failures, network failures or hardware failures, but maintenance is the much more problematic aspect today. Hardware and networks have become so good that they're really not the big issue anymore. What's at issue today is maintenance operations, right? Advanced conflict detection, conflict management, that's important again, because if you have lots of different servers all getting data, you really need to figure out, who's right, who's wrong, and what you need to do in case of conflicts. There's things like distributed sequences, okay? Again, if you have 2 servers and they both get transactions, and let's say the transactions are numbered using a sequence, well, you need to make sure that the sequences don't step on each other. Replication sets, so that you can figure out what do you replicate where, right? So sometimes you can't replicate, let's say, all the German data to France. You want to keep that data in Germany and the French data in France, but you want to replicate the master data, for example. You need capabilities to expand and consolidate the cluster. You need to do rolling software upgrades. Those are things that a good Postgres hacker may think that, oh yeah, I can make it work. But the problem is only this person can make it work. And even then it's really, really fragile and not something that we would recommend, especially when we're talking about rolling schema changes and schema migrations, which again is something that is likely to happen in a distributed cluster. So PostgresBDR is building on logical replication and on all the advances in Postgres to provide a solution that allows us to use logical replication as a tool for extreme availability, or as we call it, always on. So let me walk you through the details here of how this works. So this is a sample always on architecture for PostgresBDR. It's the architecture that we call Platinum. I will also show you other architectures that we call Gold, Silver, and Bronze. I'll walk you now through always on Platinum and how it works, what the components are, and what their roles are. So you can see here, let me start on the left in Data Center A, upper left-hand corner, you see two pairs of PG Bouncer and HA proxy servers. Those are the entry points where the applications connect to the data center, mostly, but it's not the only way, but most of the time using a multi-host connection string. So there's two servers that are at the entry point. As we all know, PG Bouncer allows us to manage the connections and provide connection pooling. HA proxy, together with HARP, our high availability router, manages the connection to the BDR servers that are actually the database servers. Okay, so in Data Center A, there is two BDR servers, one that we call the lead master and one that we call the shadow. The lead master is the one actively taking the transactions. So you can see the solid arrow connecting from the HARP pair to the lead master. That's where the transactions flow. Then there is a mesh network between the lead master, the shadow master in Data Center A, and all the other BDR servers. So they all replicate to each other. Now, only BDR1 in this case is actually getting active changes, and they're propagated throughout this mesh network to the other participants so that there's always redundancy of data and redundancy of capability. There's also a logical standby, and I'll come to the role of the logical standby in a minute, and a witness in an independent location. The witness is there to make sure that in case of a data center failure, we still can establish a quorum and can take certain decisions that actually require raft consensus in this case. BDR uses raft as a consensus mechanism, okay? So if there was a failure now of lead master 1 or maintenance of lead master 1, then HARP would identify that, hey, lead master 1 is no longer available. Let me redirect the traffic to BDR2. BDR2 then becomes the lead master, and all transactions continue as before. The application does not sense an unavailability of the service. Yes, there's reconnects that are required, but the service remains available. And the shadow master, so the former shadow master, now BDR2, can instantaneously take over processing of new requests. Okay, and then these new requests get replicated again to the other BDR nodes in the cluster. When BDR1 comes back online, be it after maintenance or after repair, well, then the replication from BDR2 will automatically restart again to BDR1 and bring BDR1 back up to speed. The purpose of the logical standbys is there to guarantee ongoing high availability should there be a unrecoverable hardware failure, let's say with BDR1 or BDR2. Then the logical standby can quickly be promoted to become a new BDR node, so high availability is restored very quickly. And that's important, especially in larger databases, multi-terabyte databases, where otherwise recreating a new BDR node could take a long time because it would have to be recreated from backup. Right? So this is one of the deployment architectures for PostgresBDR, and this is comparable to what Oracle does with their maximum availability architecture, right? The maximum availability architecture also exists in 3 variants. The PostgresBDR standard architectures exist in 4 variants. I'll show you the other. Yeah, so this is one of the variants, and I'll get back to the other variants in a couple of minutes. I'll first compare this to Oracle RAC, because you may ask, how does this actually replace Oracle RAC? Well, Oracle RAC here in the 2 data center setup as one of their maximum availability architectures uses a shared storage mechanism. Okay, so you have multiple RAC nodes, and they talk to the same storage, and the RAC nodes are connected with a high-speed interconnect to make sure that the memory that the memory stays in sync. Okay, and then there's a replication network between both locations. BDR is different. BDR uses a shared nothing architecture, so there's no shared storage. Every single BDR instance actually has its own storage. And then the BDR nodes use a replication mesh network to replicate to each other and keep each other in sync. Okay. Now, the big advantage of that is that BDR does not require any kind of specialty hardware. It doesn't, it works with SANs, but it doesn't require a SAN. It doesn't have the same specific requirements that Oracle has. It does not require or does not benefit from proprietary hardware, and it can run in every cloud in almost every data center architecture. Okay, so BDR takes a very different approach from RAC. It uses a shared nothing architecture, whereas RAC uses a shared storage architecture. So as I said before, BDR comes in different variants, different architectures, just like Oracle's MAA. We have 4 standard architectures. That doesn't mean that you can't use variations of these standard architectures, right? They're completely adaptable, and our professional services team would work with you to make any required changes to these architectures. But the 4 architectures going out of the box is the Platinum architecture that I just talked about a minute ago. Then, stepping it down one step, we would go to Gold, and the difference between Platinum and Gold is that there are no logical standbys here. So which basically means in case of a hardware failure, it can take a little bit longer to reestablish high availability and local high availability. The system keeps on running, right? There's multiple copies of the data. So proper high availability is proper availability of service is still guaranteed, but high availability, local high availability requirements would not be met until a new BDR node has been instantiated. If we step it down one step, we go to Silver. Silver has a single active location, but has multiple different BDR servers, and can restore high availability very, very quickly. Okay, and then the Bronze architecture, which is the basic architecture that customers use for departmental solutions or for development solutions, is really focused on a single data center location, where you can move the barman node offsite, but it has a lower availability rating than all the other architectures. So the key element here is that PostgresBDR can be deployed in multiple variations and multiple versions of the architecture, all depending on the availability requirements, traffic requirements, and requirements of geographic redundancy or just local hardware redundancy. So let me just dive quickly into one case study here. One of our customers, ClickUp, they're a very large, very successful SaaS project management software. They use PostgresBDR for replication between multiple instances to support their massive growth in Asia, North America, and EMEA. And they have proudly said that BDR has really helped them to get upgrades with zero downtime and resolve any problems that they had in their environment without taking the whole environment down. So this is an example of somebody who uses it for geographic distribution. There are other companies and or other customers, and the links will be sent with the presentation, like Thales, for example, the software, the security company that use BDR to make sure that that their SafeNet key secure environment is always available for their customers to provide single sign-on environments. Or ACI is a very large payment provider for the major banks. They're also building on BDR to make sure that they have absolutely no loss of transactions in a extremely highly available environment. So you may ask, hey, how about RDS, Aurora, and all the other DBASs that are being provided by the cloud providers? Are they an option? Well, in our view, they're not an option. They're not an option because they have not figured out how to keep the service up and running when a maintenance operation is required. Not necessarily a maintenance operation of the underlying software or hardware, but also a maintenance operation of, let's say, the schema, the data, etc. So just to make my point here, I showed you before what the availability requirements are if you go to 4 nines or 5 nines, okay? So to show very clearly here, excuse me, that the Aurora, for example, is not something that you can use for that, even though there is a common perception that Aurora provides you extremely high availability. Aurora provides you good resilience and makes sure that there's always multiple copies of your data. But this quote from the Aurora documentation shows very clearly that trying to get to 4 or 5 nines with a solution like Aurora that actually only has one active server. Yes, it has multiple copies of the data, but only one active server, right? That is nearly impossible. With AWS stating that it will take 120 seconds to restore the service after a failure, and sometimes or often less than 60 seconds, you can't get there if you only have a very, very small budget for unplanned downtime throughout the year. Okay, so if you want to go to 5 nines of availability, then a solution like PostgresBDR, or by the way, like Oracle RAC, is required, because they do share a lot of things, right? They do share the fact that there is multiple instances of the database server collaborating together to meet requirements. So you can't take one of those instances down at any point in time and still maintain the service. So that is what PostgresBDR and RAC have in common. They realize the sharing of the data a little differently, shared storage versus shared nothing. But they do have multiple instances of the database server running and supporting the service at the same time. Solutions like Aurora or RDS don't do that. They have multiple copies of the data, but not multiple copies of or multiple instances of the database server to provide high availability. Okay, so why make the switch? Okay, why would you do this? Well, first is, if you just add up the cost of Oracle RAC, and that's why a lot of customers come to us, they say it is so expensive, terribly expensive, and it's restrictive because you can't run RAC on every cloud. You have to go to OCI or in your own data center. So if you have a strategy to shutter data centers, there's only one place to go. That may be a good place. I'm not saying it's a bad place, but there's only one place to go. So there's a cost constraint, and then there's a contract constraint, what you can do with it. With Oracle RAC, obviously you pay for licenses, you pay for maintenance, you benefit from proprietary hardware. It's true today you don't have to use it anymore, but it is still something that a lot of customers do. You certainly need an enterprise-grade SAN, and then, as I said, limited cloud platforms. PostgresBDR, it runs on commodity hardware, and it runs on every public cloud. And that's a huge advantage. It's a huge advantage because it puts you back in control. It gives you all the flexibility that you need. Then we see a lot of customers combine that with the innovation, right? I mean, Bruce Momgen has always told me people come to Postgres because of the cost, but they stay because of the innovation. And I think that's absolutely true. So once you get onto Postgres with BDR, then you cannot just run in every cloud, but you have all the multi-model capabilities of Postgres with PostGIS, which I think is probably the leading geographic information system extension for any database. Things like JSON-B, key value pair, specialized data types for IP addresses and ISBN numbers, etc. And then a lot of people combine that with EDB Postgres' advanced server, which gives you then Oracle PLSQL compatibility. So now you have two very, very interesting properties. You have high availability, just like Oracle RAC, but you also can take your code that ran on Oracle, that you developed for Oracle, that's a huge investment, and you can run that code in Postgres, okay? So bringing all these things together is why we have such an interest in PostgresBDR, and that's why people like ClickUp, Thales, ACI, and quite a few others that I can't talk about are adopting PostgresBDR as an extremely high availability alternative to Oracle RAC. So from a conclusion, PostgresBDR is different as a high availability solution because it's built on multi-master logical replication using a mesh-based architecture. And the mesh-based architecture is really important to achieve the type of high availability that we're talking about. It has multiple deployment architectures, just like MAA, ranging all the way, in this case, from bronze to platinum, really focused on meeting your high availability requirements. These architectures can be modified. I mean, we do that in conjunction with our professional services team, can be modified and adapted to your needs. And then, we know that we can achieve 5 nines availability on-prem and in the cloud. And that is really a huge differentiator and a reason why customers are adapting this, because it's the first time that we know of a Postgres alternative to Oracle RAC that can compete in terms of high availability. And then it's a very, very significant cost reduction. And don't forget about the flexibility and innovation advantage. So a number of resources here about BDR. We just published 2 white papers about BDR. A lot of the content that I presented here comes from those white papers. They are quite extensive, and they will give you hopefully a good overview of how BDR works, how you can use it, and why the claims that we're making, are really, achievable. My colleague Simon Riggs did a very good webinar for how to use BDR for upgrades, right? And again, upgrades is a key maintenance operation that you have to be able to do, right? It's one of the reasons why, always on is so different from highly available. Highly available buffers you for failures, hardware failures, network failures, OS failures. Always on is a technique to make sure that your service is running all the time, even when you have to do maintenance, right? And we have too many customers who say, well, I just skip this maintenance window, because I don't have a maintenance window. Well, that's not a tenable situation. First, you run with buggy software, and then you really have compliance issues. So you can't. That's not an option. Simon also did a very nice presentation at Postgres Vision, right? How to build a business that never sleeps. We highly encourage you to take a look at that. And then ACI did a very nice presentation. Dominic Mortimer from ACI did a very nice presentation about how they're using PostgresQL BDR. That was done at the Second Quadrant Conference in 2019. Absolutely worth taking a look at, because there you have a customer talking about their experience, their firsthand experience. A number of blogs that really go into the details. how it works, and how software packages can take advantage of high availability and resilience. Tom Kincaid wrote a very nice piece of how you use object relational brokers together with something like BDR to handle transaction retries in case of failures, etc. Okay. All right. So that's enough of it from me. I think we have a number of questions. Ina, can you lead us through them?
Yes, we do, Marc. So thanks so much for the presentation, first off. And then question number one is there a synchronous replication setup between BDR1 and 2?
No, I don't think so. I know we have a lot of customers out there that are running on BDR1. I'd encourage you to get in touch with us to develop a plan to get you from BDR1 to BDR3. BDR2, I think, is going to be end of life soon, so I really wouldn't encourage that move or end the support. And for those of you that are not familiar with it, BDR1 and BDR2 or open source versions of the software. BDR3 is closed source. So I'd recommend getting in touch with us to discuss your alternatives.
Great. Okay, question number two. So why the reconnect required from application when PG Bouncer plus HA proxy is configured as connection pool? Is there a way we can avoid the reconnects?
Yes, there are. Okay, so PG pool can be configured in two different ways, and I shouldn't have said what I said. That's a very good point. It can be configured in session mode and transaction mode. And in transaction mode, there are ways to avoid the need for a reconnect under certain circumstances. But basically, what happens is, the database switches from one host to the other. And Postgres doesn't offer something like TAF, transparent application failure, that Oracle has. So basically, in that case, the application has to reconnect, right? So the application will be told that, hey, the connection to the database has failed, and you should reconnect. Most applications will do that transparently. There won't be a huge issue, but that is really something that has to happen. Now, in this specific situation, as I said, there may be ways to configure PG Bouncer in such a way that it's not necessary, but that all depends a little bit on your application requirements and can we use PG Bouncer in transaction mode.
Good. Okay. All right. Another question here: how PostgresBDR replication is enabled with a GCP AWS browser region when HA node is having a latency in Google App Engine that runs Java, Spring, Kotlin, CLI in a compatible Kubernetes instance for AI ML application?
Okay. All right. So I think that's a loaded question. There's like half a dozen things in there. So first, we will provide a BDR operator as part of cloud native Postgres towards the end of this year. Please get in touch with us so I can get you the exact dates. It will be available first within the region and then cross-region a little bit later. So that operator is what we would use with containers. So we have EDB Cloud Native Postgres, which has an operator and containers, and the operator orchestrates the containers. There will be an additional operator for BDR, and that will allow you to do, I think, what you're describing in here.
Got it. Cool. Actually, Marc, I'm going to go back to the PG Bouncer and HA proxy question. There's a follow-up here, and it says, when used in single master, not multi-master, can we still have the reconnects?
Yes, because the let me just maybe go back to that picture here. It's probably easier to explain in here. Okay, so what happens is when BDR1 fails over to BDR2, right, and the application is connected via PG Bouncer to BDR1, then it will lose its connection to the database when BDR1 fails. So it will not show errors during normal operation, right? So during normal operation, there's no need to reconnect. But if there's a maintenance operation, meaning the operator is taking down lead master BDR1, then the application will need to reconnect to BDR2. As I said, there may be ways to configure PG Bouncer in transaction mode to avoid some of those, but that's not a guarantee. Now, one thing that we've done in HARP, right, our high availability router, is it will make sure that connections are bled down. So if you have a connection from the application to BDR1 and you want to switch over to BDR2, so an operator controlled switchover, then you can tell PG Bouncer to finish up whatever it needs to finish up on a current transaction, on a current session, and then not accept new work, so that basically the load on the visibility of this operation to the application can be minimized.
Good. And actually, so I think it has to do with this slide. Terry is asking, is barman a requirement?
Okay, you do need, okay, so do you need backup? And so I think there's two questions in there. First, do you need backup and recovery in a multi-master environment, right? Because you got multiple copies of the data, do you want to take a chance and actually not have a backup? Because in this picture here, you have at least 6 copies of the data. So, and they're actually in 2 data centers. So why have a backup? Well, the reason for the backup is that you should really protect yourself against operator error and data corruption. And so you do need to be able, at least that's what we believe, you do need to be able to travel back in time. And so Barman protects you there against what I would call the DBA oops moment. I have been a DBA, and that did cause at least one oops moment in my career. And I was glad that we had a backup tool where I could kind of get my data back, right? Because if a DBA goes in, makes a mistake, blows away a table, that transaction will be replicated instantaneously to everybody else. That table will be gone. So you don't need Barman here to protect against hardware failure, but you do need something like Barman to protect against DBA error and then compliance requirements, so that you can go back in time. Barman is our preferred tool that has been optimized to work with BDR. If that's the specific question, if you need a different backup solution, then this is something where our professional services team could engage with you to figure out, okay, what are the options and what are the requirements?
Great. Okay, another question. What does the witness do exactly? Does it resynchronize data between DB after crash?
No. It's like, okay, let me try to walk you through that in this picture here. Okay, so there are certain operations. Let's say reallocation of new sequence numbers that require consensus. Okay, so let me start with what is reallocation of new sequence numbers. So let's assume our application assumes that the database will automatically assign a primary key from a sequence, right? It's not an unusual approach where you just say insert something and I ask the database server to give me the primary ID. Okay, it's pretty standard operation. Now, when you do that in a distributed environment like this, where there are up to 4 active databases in this picture here, right? Then when the application switches over from BDR1 to BDR3, for example, then how does BDR3 make sure that it doesn't reassign the same sequence, the same ID that BDR1 had already assigned? To do that, we separate the sequences and allocate sequence blocks to the different BDR servers. Okay, now let's assume there is then, so assigning new sequence blocks to a BDR server is an operation that requires consensus. So now what happens if there is a failure of a data center here? So right now I have 5 active servers. Okay, let's say data center B fails. now in data center A plus my witness, I have 3 out of 5 because BDR1, 2, and the witness center, they don't know that the data center failed. They just know that BDR3 and 4 are not responding, okay? So can they be the majority of the cluster as far as they know it? Yes, all 3 together can be the majority of that cluster, so they can do operations like allocating a new sequence block, okay? Now, if the BDR witness was not there, then there would only be 2 out of 4, and the 2 are not the majority, so they don't know for sure if they can actually do this. Okay, so in that case, operator intervention would be required. Now, these type of consensus operations are not needed for every single transaction. So even if the BDR witness was not there, operations would just continue. It's just that certain things that require consensus would then require operator intervention, and the operator in that case would manually part one of the BDR nodes, so either 3 or 4 from the cluster, meaning it would tell BDR1 and 2 that, let's say, BDR3 is no longer in the cluster. In that case, BDR1 and 2 would be the majority of the cluster as far as they know it, and again, they could take consensus decisions. I hope that explanation made sense.
Okay, great, Marc, thanks. Okay, another question. When a BDR server goes away and storage becomes out of step with the other node, how are the changes applied before the node joins the HA cluster and accepts connections?
Okay, all right. So basically what happens is BDR uses the Postgres replication slot to track what transactions have been applied where. So for example, if BDR1 is our lead master, BDR2 is our shadow master, right? BDR1 uses a Postgres replication slot to track what transactions have been sent and accepted by BDR2, right? And then they're being taken out of the slot. So it's pretty standard. It's a pretty standard Postgres operation. So what happens now when BDR2 goes offline for any whatsoever reason, BDR1 in its replication slot will just keep track of everything that has not been applied yet to BDR2, okay? So when BDR2 comes back online, the replication slot will be used to just, send it everything that, and then it commits that, yep, I got it, that has not been sent yet to BDR2. Okay, so that was the first part of the question. How do you apply all the changes? The second question is, well, it doesn't actually fail back automatically, right? HARP will keep the traffic with BDR1. Switching it over is not something that happens automatically. That's an operator initiated operation. So the operator won't do that until the replication lag between BDR1 and BDR2 has been resolved, and that again is tracked in our Postgres Enterprise Manager, PEM, which is like Oracle Enterprise Manager. It gives you a graphical view of the replication lags, etc. So that's how we make sure that this isn't a problem, right? Using the replication slots. And the second thing is it's a operator initiated operation, and the operator can see the replication lag before redirecting traffic.
Great. Okay, so we are almost out of time, so there's room for one more question, Marc. So the last one is there a BDR1, BDR2, and BDR3 comparison document available for review?
Oh, I don't know. I'll figure it out and I'll get back to you. I'm sure there is something, at least conference presentations, but off the top of my head, I wouldn't know. But I'll get with product management and I'll get back to you.
Great. Awesome, Marc. So I see there's still questions coming in, so we would not have time to answer them just at this time, but we'll make sure to follow up on them after the webinar. So it's 10:59 already. Thank you all so much for joining. Marc, thanks for the presentation. Again, we will be sharing the recording and the slides after this webinar. So thank you so much, everyone.
Thank you.